there's some things that you need to know what not to do. When you're using a biosafety cabinet, you have to use it properly or it doesn't function right. And if it's not functioning properly, you can lose containment, which then you might as well work right here. You can contaminate your research material, which, you know, you're putting a lot of work and effort into getting good research data, so you don't want to do that. You can also contaminate the environment, which obviously we don't want to do. So there's a couple of big items that we need to know about. A biosafety cabinet, just because it has cabinet in its name, doesn't mean that it's to be used for storage. You should only take the items into the cabinet that you need to use for your experiment. When you're done, you should wipe them off with disinfectant, and you should remove them from the cabinet. And then you should disinfect your work surface. You shouldn't store things in there. Overcrowded cabinet can disrupt airflow, can cause turbulence, and can cause cross-contamination, which would contaminate your work product. So too much stuff in the cabinet is a problem. The other things you don't want to do is, I said there's an airflow grill right here, and if you've worked in a biosafety cabinet, you know what I'm talking about. Right in the front, you'll see there's a whole bunch of little holes. You don't want to block that. That's imperative that is kept free, because that's where that air comes in and flows down into the cabinet. That's what basically protects you as a worker. So you need to make sure that you don't have stuff laying on top of that, like a notebook or your pipette men, things like that. And then along the lower side walls and the back side wall, you'll also see holes. Those are called your grills. You need to keep those free too, because that's where your air circulates to recirculate through the cabinet for your work surface airflow. So you want to make sure that you don't have stuff blocking that, like pipette tip boxes and things like that. Biosafety cabinets, they are designed for one person. Doesn't matter how big or how small they are. They are made for a single operator. That's how they are designed, and that's how they are tested and certified. So a lot of people think that if you buy a 6-foot biosafety cabinet, you can work 2 people in a biosafety cabinet side by side. That is not the case. Just because it's big enough to have 2 workstations doesn't mean that's what it is for. So one person working at a time in a biosafety cabinet. 6-foot biosafety cabinets really, in my personal opinion, are a waste of space and a waste of energy. Unless you have a need for like a large piece of equipment or something that needs containment and you have to put it in a biosafety cabinet, there's really no need to buy a 6-foot biosafety cabinet because you can't work 2 people together. You don't ever want to store anything on top of the biosafety cabinet. That's where your exhaust filter is, so you don't ever want to put anything up there to block your air exhaust. It also gets pretty hot up there. So if you start storing, that's where your motor is. If you start storing stuff up there, like cardboard boxes and things like that, you run the risk of starting a fire. If you're doing vacuum, anything with a aspirating tissue culture, things like that, where you've got a vacuum pump or hooked up to building vacuum, you need to have a trap, glass trap, or if you have a glass trap, it needs to be in secondary containment, or you need to have it in a plastic Erlenmeyer flask. You also need to have a filter on that trap. We also don't want you using open flames in a biosafety cabinet, so no Bunsen burners. Gas burners in biosafety cabinets really contribute to heat buildup, which is very bad in a biosafety cabinet. A fire in a BSC is very bad. The motors in those cabinets are not spark proof, so if you start a fire in a biosafety cabinet, it's not going to stop. It's just going to create a bad fire. It's going to burn the whole thing up. The other thing is those Bunsen burners disrupt the air streams that keep the work area clean and lead to cross-contamination of your product, which we don't want. If you have a biosafety cabinet that has a UV light in it, we don't really recommend that you use the UV light because most people don't use them properly. People turn them on and think that they're decontaminating their biosafety cabinet, but they don't ever check the UV light for efficacy. Or they don't clean it. They just gather dust, and so they don't really use them the way they're intended to be used. But if you are using a UV light, it cannot be on while anyone is in the room or anyone is using the cabinet. The newer cabinets actually have interlocks with the UV light, so you can't actually turn the cabinet on while the UV light is on. You can't open the window while the UV light is on. But we don't even want people in the room while the UV light is on. Those can severely damage your eyes. So just make that your practice. So any questions about engineering controls or containment devices? There are other types of containment devices, centrifuges with aerosol-proof cups, localized ventilation. You might see like a downdraft table in a necropsy lab, or if you're working in a chemistry lab or something where they have a localized hood over a particular lab bench. Those are all types of engineering controls. A gas cabinet where you might have a particularly hazardous gas cylinder and you have to monitor for leakage. Those are all engineering controls. We have quite a few of those over in the chemistry department. But all of those things, those are your first line of defense. Okay, that's the first thing we want to do. When we do our risk assessment, we say, what are we working with? How can we mitigate through engineering controls our risk? Okay, so we've done this. We say, okay, we're going to work in a biosafety cabinet. Okay, now we're going to look at work practices. Work practice controls are behavior-based, and they're intended to reduce the risk of exposure by changing the manner in which we perform our tasks. And examples of this include proper hand washing, no eating or drinking in the lab, proper disinfection of work surfaces and equipment with appropriate disinfection. So this is our second line of defense. Okay, this is what we do next. So we've looked at our engineering controls. Now we're going to write our SOPs. Now we're going to say, what standard operating procedures do we need to make sure that we're working safely in the lab? You also might hear these called administrative controls. That's kind of a synonym for work practices. So I'm going to go through some of the essential work practices for BSL-2 because that's what most of you are going to be working at. Signs and labeling. So if you're working in a BSL-2 lab, you need to make sure that the biohazard symbol is posted. If biohazards are used in the lab, the biohazard symbol or label has to appear on the room sign. If they are used or stored in equipment, then the label has to appear on the equipment. So here at OSU, we have EHS actually has a room sign that we generate for the labs. And they request a room sign, they check off what they're using in the lab, and we generate the room sign, and we ship it to them through campus mail, they put it on their doors. This is the information that goes on the room sign. So the labs that you're working in should have one of these. We ask them to update it anytime they change hazards, anytime the contact information changes, and we send them a new one. So the PI's name has to be on there. They have to have their emergency contact information. And then the hazard level, or what hazards they're working on. If you are working in a BSL-2 lab, it will have this symbol on it. And then there's other choices for carcinogens, highly toxic material, reproductive toxins, radioactive material, water reactive materials. What else is on there? There's about 8 or 10 choices that they can choose from that need to be labeled on the lab. And then if they have any special entry requirements, they can list that and it would show up down here. And that gets posted on their lab door. Within the lab, anywhere that they are using or storing biohazards, such as centrifuges, incubators, freezers, biosafety cabinets, we give out stickers that look like this. And then they just post that on the piece of equipment. This is mainly for not the people that work in the lab, but people who enter the lab, like maybe maintenance, housekeeping, people like that. We train them. They know that if they see that sticker, they don't touch that piece of equipment. Only qualified people who have been trained, or that if they see that that piece of equipment's been decontaminated, then they're able to work on it. Obviously, no eating, drinking, cosmetic application, or storing food or drink in the lab. Consumables can be contaminated with chemicals and biohazards when they're present in any lab space. As I mentioned yesterday, it gets to be a problem in some of the buildings, but we are very strict about this. Some of my lab's inspection staff will actually take your coffee, water, whatever it is, take it from you and take it outside. I mean, this is a big deal. We don't want people getting sick because they have contaminated their food or drink. So, and if you work in a radioactive materials lab, this is a huge, huge no-no. If they even see evidence that you threw something away in the lab, you'll get written up for it. So, mouth pipetting, we talked about yesterday. We want you to use mechanical pipetting device. Obviously, you can contaminate your hands and fingers and disseminate agents in the workplace if you are pipetting by mouth. Avoid aerosol production. Pipetting, sonication, homogenation, and centrifugation of agents can produce infectious aerosols. Some of those seem obvious. I mean, homogenizing, obviously we are producing aerosols. Centrifuging produces aerosols. A lot of people don't think about pipetting producing aerosols, but it does. It actually produces quite a bit of aerosol. So if you are pipetting risk group 2 agents, we want it done in a biosafety cabinet. We want you to make sure that you are, manipulating infectious fluids carefully so that you're avoiding spills and production of aerosols. Work in a biosafety cabinet when you're doing these procedures. And if you are centrifuging any risk group 2 materials, then you need to use safety cups. And these are the cups that you actually put your tubes in. They have a lid that is gasketed, and then it goes into the centrifuge. So we're not talking about the actual tube itself, but either the rotor itself has a gasketed lid, and the rotor can be removed because you are going to load and unload the safety cup or the rotor in the biosafety cabinet. The reason for this is if you have a tube that breaks, we want you to be able to take that out and unload it in the biosafety cabinet. We don't want you to open it in the centrifuge, sitting out in the middle of the room, and release the aerosols into the room. Okay?